Hi friends, in this video we are going to see about bubble sort. It comes under unit 2 in the AA subject. So sorting is nothing but arranging values in per specific order. It may be ascending order and descending order. So now we will see about an bubble sort, and it is now we are going to do this sorting in ascending order. So compared to the first, we are comparing the adjacent element of list and swap it if we are out of order. This will be done repeatedly until we will getting the sorted element. So here also we are using the same values. So here ith is in one pass and j is in another pass. So for here now we will compare the elements. First two elements will be compared. If it is lesser, the lesser value will be come front. So now we are comparing 89 and 45. Compared to 45, 89 is higher value, so it is moved to next position. So this is what jth pass, jth values 0th pass. So now we are comparing 89 and 68 in pass 1. So 89 and 69 is compared, 68 is lesser, so we are swapping 68 and 89. So in second pass, again 89 and 90 is compared. We no need to, the 89 is compared with 90 and it is higher value, so we are keeping the same order. So now we are comparing in third pass, we are comparing 29 and 90. Two elements are compared, so 29 is lesser value, so 29 is come front, means swapped with 19. So in fourth pass we are comparing 90 and 34. So 34 is lesser value, 34 and 90 are swapped. So in fifth pass we are comparing 90 and 17. 17 is lesser value, so both values are swapped. So in ith pass, this is the first one. So now we are comparing 45 and 68, the same, so we are keeping the same. In first pass of jth value, it's compared with 68 and 89, it is same, so we are keeping the same. And in second pass we are comparing 29 and 89, so now we are comparing 29 and 89, it is swapped, it is lesser, so it is swapped. In third comparison we are comparing 89 and 34, so it is lesser, so both the elements are swapped. And again fourth pass, 89 and 17 are compared, so 17 is lesser, so it is both are swapped. And now it is already sorted, so after that we don't need to compare. In the second pass, so the value will be continued. So now we are comparing 85 and 45 and 68, it is same, so now it is compared 29 and 68, it is lesser, so in first pass we are shifting or swapping 29 and 68. In the second pass we are comparing 34 and 68, it is lesser, so it is swapped. In third pass we are comparing 68 and 17, it is lesser, so it is swapped. The last two elements are already sorted. In the pass 3 of ith element, so now we are comparing both the elements 29 and 45, it is same, so we are keeping the same. 34 and 45 is compared, it is swapped. And again 45 and 17 is compared, 17 is swapped, and remaining elements are not swapped, not checked, because it is already sorted. In ith pass fourth element, we are comparing 29 and 17, it is same, and we are keeping the same, and 17 and 29 are compared and it is swapped. So in the past 5 of ith element, so now we are comparing 29 and 17, so the 17 is lesser, so it is swapped. So this is so remaining elements are swapped and sorted as per the previous passes. So now we will see for array, in algorithm. So array consists of 0 to n minus 1 and length, and output is also same, but it is in ascending order, it will come in ascending order. So for in first for loop it starts from 0 to n minus 1, and for second for loop, ith for loop, 0 to n minus 2 to n I minus I. So here what happens is, both the elements, first element and second element will be compared, and if it is lesser, and first element and second element will be swapped. This process will continue until the ith passes are this second innermost for loop will be executed first, and for ith passes external for loops are executed. So this will be done until we get an sorted array. So for input size here also it is n, and key basic operation is comparison a of j less than a of minimum element. This is the comparison, and here basic operation is 1, and it starts from 0 to n minus 2, and jth value is 0 to n minus 2 n minus I. So here it compares upper bound minus lower bound. So we are substituting here, and we will get n minus 1 minus I. So again this will be substituted, and we will get this. So again this will be so upper bound and lower bound are compared, and we are getting this value. So again this will be rewritten as n minus 1 and 1 and summation of I. So here it is n minus 1, and this will be substituted upper bound minus lower bound, and we are getting n minus 1. Here n minus 1 and n minus 1. For this case, summation of 0 to n minus 1 I, we have a formula that is n of n plus 1 by 2. So this will be substituted here. And this will be rewritten as n minus 1 minus lower bound. So this will be rewritten, and we will get this one, and LCM is taken, and after solving the equation we are getting n square minus n and by 2. So here we have rewrite as n of n minus 1 by 2. So here n square is the highest power. The order of growth for this particular algorithm is n square. So that is what number of swap is, order of growth is big O of n square. So here also we are considering all the elements. So the best, it will comes under worst case. Thank you.